Today, just to show you a breakdown of what I've been doing over the weekend. So the plan was to predict malaria cases in Abuja and Kano in Nigeria. So you can see the different libraries that we use. So most importantly, the Pandas, Pandas will display maps. Then Scikit-learn, you can see Joblib for loading our exporting the models, and then you can see Folium for displaying our maps, and Matplotlib for plotting graphs and charts. So you can see loading the CSV file. You can see like a snippet of the data sets that we have. And then here is to display the location of our data. You can see the location of our data, the malaria cases in Abuja. And then next is to define which of the variables are the dependent variables and independent variables, like the targets, the dependent variables like malaria cases. And then we have the rainfall data as at 2020, temperature, land surface temperature as at 2020. Then we have relative humidity as at 2020 and enhanced vegetative index as at 2020. And then this is to prepare them in terms of the X and Y. And then we needed to split our variables into train and test. So we have this, so you can see the size of our train and test is 0.2, which means 0.2 splitted into 80% for train samples and then 20% for test samples. And then we have ANOVA. You can also test ANOVA to see how the different variables are doing, and then after that to plot it. So next we had to define the model. So in this course we had to use 5 models: logistic regression, naive Bayes, Bayes rather, random forest, support, vector machine, gradient, and then after that here the part to save our model, then the performance, we have to store the performance, model performance, and then here is to train, evaluate, and then to save the model. So you can see this is to train, this is to make predictions, and then this is to calculate their performances, and then to store the result and also print. So you can see the results here. You can see the various results here. For the logistic regression, you can see the accuracy. For the naive Bayes, you can see the accuracy, and then down to the last model, which is the gradient boosting. And then we needed to compare the results, so we can see the different results, the accuracy, precision, recall, and F-score, and then choose the best performing model. So as you can see, the random forest is the best performing model, and then we had to, this is just to plot the different results, the comparison charts, yes, of the performance charts for different models. And then this is just what we've been doing. So with this now, the models are already saved, so I can pick any of the model, maybe the model that is performing better, which is the random forest, to then start predicting malaria cases for Abuja. So I can bring in rainfall as at 2024, temperatures at 2024, and then predict what will be the case of malaria in the entire Abuja with this data analysis that I've done. Thank you.